This is first lecture of class 9th mathematics, the number systems. In this lecture we will discuss about some basic number systems including natural numbers, whole numbers and rational numbers. So first of all we will look at the definition of the natural numbers. So the numbers which are used for the counting purpose, they are the natural numbers. So these are the numbers 1, 2, 3, 4, 5, 6 and so on. So if we talk about the smallest natural number, so 1 is the smallest natural number, and if we talk about the largest natural number, there is no largest natural number. These numbers you can find the next number after 6 it is 7, then 8, 9, 10. There are infinitely many numbers. Next is the collection of the whole numbers. So whole numbers, basically we are saying this 1, 2, 3, 4, 5, 6, all these natural numbers are the whole numbers, and apart from these numbers, this number 0 is there, which is a whole number. So if we talk about the smallest whole number, it is 0. So whole numbers are all natural numbers, and the number 0, it forms a collection of the whole numbers. Just like the natural number, there are infinitely many whole numbers, and 0 is the whole number which is not a natural number. Next we are talking about are the prime and the composite numbers. So for the definition of prime numbers and composite numbers, we are looking at the factors of a given number. If suppose I am talking about the number say 9, I am talking about its factors. Its factors are 1, 3 and 9. Suppose I am talking about the number 7, its factors are 1 and 7. If I am talking about say number 12, its factors are 1, 2, 3, 4, 6 and 12. Now if I am talking about say number 1, its only factor is 1. So what we see is that there are three kind of cases. The first case is those numbers which have exactly two factors. Suppose I am talking about say number 3, it has factors 1 and 3. So I am talking about the numbers which have exactly two factors. These are the numbers. I am talking about 7, I am talking about 3. So these have exactly two factors. This exactly word is very important over here, that they have exactly two factors. Then those numbers, these are called the prime numbers. If they have more than two factors, then those numbers, they are called the composite. This more than is important. Over here it is exactly two factors. Now it is more than two factors. So what we see is these numbers, this 9, 12, all these are the composite numbers. Now if I talk about the third case, I am talking about the number 1. So 1 has only one factor, it is 1 itself. So it is neither a prime number nor a composite number. This is important over here, that 1 is neither prime nor composite. So prime are those which have exactly two factors, composite are those which have more than two factors, and 1 is the natural number which has exactly one factor. So neither it is prime nor it is composite. Now next we have is the definition of co-prime numbers. So co-prime are in pairs. We are talking about now the two numbers. Suppose I am talking about the number 9 and 12, or suppose say I am talking about the number 9 and 3. So what we have seen is that 9 is composite and 3 is prime. These are individually we are talking about, that 3 is a prime number and 9 is a composite number. Now if I look at the HCF of 3 and 9, we have seen the factors of 3 are 1 and 3, factors of 9 are 1, 3 and 9. So their common factor is 1 and 3. From 1 and 3, the highest common factor is 3, which is not equal to 1. It means these two numbers, these are not co-prime. So what definition of co-prime we have is that their HCF should be equal to 1. Now suppose I am talking about, say, the number 9 and number 8. Now 8 is having the factors 1, 2, 4 and 8. So what is HCF of 9 and 8? HCF of 9 and 8 is 1. We have seen that 9 and 8 both are composite. But this pair, we say these 9 and 8, they are co-prime. If I am talking about the number 9 and 12, so their HCF is, we are seeing over here, it is 3. HCF of 9 and 12 is 3, which is not equal to 1. So these two numbers, these are not co-prime. Suppose I am talking about the number 7 and 3. Their HCF is 1. So 7 and 3 are co-prime. So co-prime, when we are talking about two numbers. We are taking a pair of numbers, and if their HCF is 1, then we say that those two numbers, they are the co-primes. Next definition we have is the definition of integers. So first we have seen the natural numbers. These are 1, 2, 3, 4, 5, 6 and so on. These all numbers, these are the natural numbers. So all these natural numbers, these are called the positive integers. Then negative of these numbers we have over here, it is minus 1, minus 2, minus 3, minus 4, minus 5 and so on. So these are called the negative integers. Then we are left with over here, it is 0. It is 0 is called the neutral element or the neutral integer. So what integer means is, we are saying we are taking all the natural numbers 1, 2, 3, 4, 5 and so on. These are positive integers. Then we have negative integers, negative of all these numbers. Then we have neutral element 0. So what we see from this definition is that all natural numbers are integers. All whole numbers are integers. 0 is the neutral integer. It is neither positive nor negative. Next definition we have is the even number and odd numbers. So for even and odd, we are talking about the divisibility with 2. Suppose I am talking about, say, the number 4. We see that it is divisible by, so what we say that 4 is an even number. Suppose I am talking about, say, the number 13 or the number 15. But we see these numbers, these are not divisible by, so what we say is that odd numbers are those numbers which are not divisible by 2. Now the next we have is the representation of the numbers on the number line. So the first kind of representation we are going to talk about is the representation of the integers on the number line. So what we do is we just draw a straight line. On this line we mark a point 0, that is the neutral point. We are saying it is a neutral integer. It is neither positive nor negative. Now on the right side of this neutral element we mark all the positive integers, and on the left hand side of this we are going to mark all the negative integers. So on the left we have negative integers, and on the right we have the positive integers. And how we are going to mark those points is, what we are going to do is, we are going to mark the points at an equal distance over here. We are going to mark the points at an equal distance over here. And how we are going to name this point? This is 1, 2, 3, 4, 5, and this line, it is an infinite line. And on the left hand side we are marking it is -1, -2, -3, -4, and so on. So these are the negative integers, and the same thing is represented in this diagram, that we have marked the point O over here. It is a neutral element over here. Then on the right hand side we have marked the point 1, 2, 3, 4, 5, and on the left hand side of this neutral element we have marked the point -1, -2, -3, -4, -5, and so on. So this is how we represent the integers on the number line. Next we are going to talk about the definition of the rational numbers. So rational numbers are those numbers which can be written in the form of p by q, where p and q are the integers and q is not equal to 0. So all those numbers which can be written in this form, they are called the rational numbers. So if we look at some example over here, if suppose I am talking about the number -3 by 2. So what we are saying, this is the number in the form of p by q. P and q, they are the integers, and q is not equal to 0. This condition is very important over here, that denominator should not be equal to 0. Then the number which can be written in this form, they are called the rational numbers. Some other examples are also given over here, that it is say 1 by 4, -3 by 2, 11 by 79. So if I am talking about say 11 by 79, what we say is 11 is just p and 79 is just q. Both 11 and 79, they are integers and denominator is not equal to 0. So it means this number is a rational number. So if any number is given to you, you will just have to see it is in the form of p by q, and denominator should not be equal to 0. Denominator should not be equal to 0 means if I am writing 2 by 0. So what we are saying, it is not a rational number. We are not talking about these kind of numbers whose denominator is 0. So if I am talking about say number 0, so what we can write, it is 0 by 1. So this is in the form of p by q, and q is not equal to 0. So our condition is that q should not be equal to 0, p can be 0. So what we say, 0 is a rational number. If suppose I am talking about say number 3, so how I can write 3 as, it is 3 over 1. If suppose I am talking about say number -7, I can write it like -7 over 1. So all these numbers, these are the rational numbers. So what we get from this is that all integers are rational numbers. Why? If we have to give the reason, we are saying suppose the integer is a, I can write a by 1. So this is in the form of p by q, where p and q are integers and q is not equal to 0. So we are saying that all the integers are the rational numbers. This is an important example over here. This is an important question over here. If we have to check whether 0 is irrational or not, what we are going to do, we are going to write 0 over 1. So 0 is a rational integer, 1 is an integer. So we are saying it is written in the form of p by q. Here p and q are integers and q is not equal to 0. But 1 over 0 is not a rational number because the denominator will become 0, and we are not discussing the numbers with denominator 0. Next we have is the definition of equivalent rational numbers. So what equivalent rational number means is, suppose I am talking about, say, the number we have discussed in this example, it is say 3 by 6 and I am talking about 4 by 8. So if I simplify this number I will get 1 by 2, simplify this number I will get 1 by 2. Simplify means I can write it like 3, it is 2 into 3. This is 4, this is 2 into 4. I will simplify this, 3 and 3 gets cancelled, so it is 1 by 2. 4 and 4 gets cancelled, it is 1 by 2. So both these numbers, these are equivalent to 1 by 2. So what we say is all these numbers, it is 1 by 2, 2 by 4, 3 by 6, 4 by 8, all these numbers, their numerical value is equivalent to 1 by 2. So all these numbers, they represent the same number 1 by 2. So we say all these numbers, these are the equivalent numbers. And what we say is 1 by 2 is their simplest form. So what simplest form means? If suppose I am talking about the number 3 by 6. So what we get is that 3 and 6, I am talking about the numbers. So HCF of 3 and 6 is 3. Factors of 3 are 1 and 3. Factors of 6 are 1, 3 and 6. So common factors are 1 and 3. So HCF, highest common factor, is 3. So what we see is that 3 and 6, they are not co-prime. So if two numbers, we are talking about the numbers p over q, definition we have given, it is a rational number is the number in the form of p by q, where p and q, they are the integers and q is not equal to 0, then we are saying it is the rational number. Now if we add another condition to it, that HCF of p and q is 1, then that form is called the simplest form. So if suppose I am talking about, say, number 7 by 9. So what we see is that HCF of 7 and 9, it is 1. So what we say, 7 by 9 is the simplest form. Now the question we have over here is, write 4 rational numbers equivalent to 4 by 7. So what we have to do is, I'm just talking about the procedure. 4 by 7 is the number given to me. So what we do is, we multiply it with 2 and we divide it with 2. So what we get is 8 by 14. So this number, we are saying 8 by 14 and 4 by 7, these are the equivalent numbers. And this is the simplest form because HCF of 4 and 7 is 1. So if we have to write 4 rational numbers, so what we have done over here, we have multiplied and divided it with 2. We have multiplied and divided it with 3, with 4, with 5. And the answers we have obtained over here, these are the answers. It is 4 by 7, 8 by 14, 12 by 21, 16 by 28 and 20 by 35. So all these numbers, these are equivalent to the number 4 by 7. Now the next thing we are going to discuss is the representation of the rational numbers on the real number line. Earlier we have seen that how we can represent a natural number. For natural number, what we have done, we have just drawn a line. We are saying we have marked a point 0 over here, that is a neutral point or neutral integer. Then on the right side of this, we have marked the point 1, 2, 3 and so on. These are the positive integers. And on the left hand side, we have marked the points -1, -2. These are the negative integers. So this is how we draw the integers on the number line. Now we have to draw the rational numbers. So rational numbers are the numbers of the form p by q. So if we talk about that q is equal to 1, then we are just talking about the numbers p, that is the integers, and we have seen how to draw the integers. Now next, suppose we are taking the value of q is equal to 2. So what we get is, when we take q is equal to 2, so we are talking about the numbers of the form p by 2. So what numbers we are talking about, we put the values over here. First number we get, it is 0 by 2, that is equal to 0. Next number we get is 1 by 2. Next we get is 2 by 2, that is equal to 1. Next we get is 3 by 2. Next we get is 4 by 2, and so on. Similarly, on the other side, or on the left hand side, we are having the numbers -1 by 2, -2 by 2, -2 by 2 is -1, -3 by 2, and so on. So what we have to do now is, we have to draw all these numbers on the number line. That is, we are going to draw the numbers with denominator 2 on the number line. So to do this, what we are going to do is, we have drawn the number line, the natural numbers. This length 0 to 1, we are saying this length is the unit length. We call this length as the unit length, and we divide this in two parts. To divide it in two parts, we mark a point over here. So what we are saying, that this portion, this is of length 1 by 2 units. This length is the length 1 by 2 units. Now what we do is, we take this much length and we mark another point over here. Then at the same this length, we are marking another point over here. Next point is this. Next we mark at a distance of 1 by 2 units. Similarly, on the left hand side, we are going to mark the points at of this much length. How we have drawn this length? We have taken a unit length, we have divided it in two parts, and we are saying this much length is the length 1 by 2 units. We take this length and we start marking the points over here, and these points are basically the points that were required. So this point is 0 by 2, next point is 1 by 2, next point is 2 by 2, 2 by 2 is basically 1, next point is 3 by 2, next is 4 by 2, 4 by 2 is 2. Similarly, on the left hand side, we are having the points -1 by 2, -2 by 2, -2 by 2 is -1, -3 by 2, -4 by 2, -4 by 2 is -2. So this is how we represent the rational numbers with denominator 2 on the number line. Now next thing we are going to do is, we are going to draw the rational numbers with denominator 3 on the number line. How we have started is, we are saying the rational numbers are in the form of p by q. When we take q is equal to 1, we are left with p. We are saying these are just the integers. Then we have taken q is equal to 2 and we have drawn the point 0, 1 by 2, 2 by 2, 3 by 2, so on. Then -1 by 2, -2 by 2, and so on. We have drawn these points. Now in the next step, what we are going to do is, we are going to take q is equal to 3. So the points we have to draw is 0, 1 by 3, 2 by 3, 3 by 3. 3 by 3 is basically 1, then 4 by 3, and so on. Similarly, on the left hand side, it is -1 by 3, -2 by 3, -3 by 3, -3 by 3 is -1, -4 by 3, and so on. So now we have to draw all the numbers with denominator 3. So the procedure is same. We are taking a line, a unit length of number. We have drawn a line over here, we mark the point 0 over here, we take this is the point 1. In the when we are drawing the numbers with denominator 2, what we have done, we have divided this unit length, this length, we are saying this whole length, this is called the unit length. We have divided the unit length in two parts. Now in this case we are going to divide the unit length in three parts. So to divide the unit length in three parts, what we are going to do is we are going to mark 2 points over here. So this one part, this will represent the length 1 by 3 units. Now what we are going to do, we are going to take this much length and we are going to mark the points on the number line. So what we have done, this is the point 0 over here. At a distance of 1 by 3 unit, this length, we have marked a point. Then again at this same distance we have marked another point. At the same distance we have marked another point. And what these points are representing, it is representing 1 by 3, 2 by 3, 3 by 3, 4 by 3, 5 by 3. Similarly, the same length we are taking this particular length and we have marked at this particular length. You will measure the length and you will mark the point over here. You will get the distance point minus 1 by 3. Next point is minus 2 by 3. Next point is minus 3 by 3 and so on. And this is how we can draw all the numbers with denominator 3. Similarly, if we have to draw all the numbers with denominator 4, so what we are going to do is we are going to take this point is 0, this point is 1. We are going to divide this in 4 parts. You will draw 3 lines over here and this distance you will get, this is basically the length 1 by 4 units. Using this length you can mark the points on the number line and you can draw all the numbers with denominator 4. So likewise we can continue and we can draw all the rational numbers. Now we are going to represent some other numbers on the number line. So suppose we have to represent the number 2 whole 3 by 8 on the number line. So what 2 whole 3 by 8 means is that this number lies after 2 and this number lies before 3. The first thing we see from this is that the number lies after 2 and before it is 3. So what we are going to do is we are going to draw the number line over here. This is the point 0, then this is point 1, this is point 2 and this is the point 3. First thing we know is we can write 2 whole 3 by 8 as 2 plus 3 by 8. So we have already moved 2 units. We have already moved to 2 units. After that we have to move this 3 by 8th part of the next interval. So 3 by 8th part means we require 8 parts over here. So what we are going to do is we are going to mark 7 lines. 1, 2, 3, 4, 5, 6 and 7 lines are there. You are seeing these are 7 lines we have drawn. 7 line means we have divided it in 8 parts. Why 8 parts? Because denominator over here it is 8. Now what this one part will represent? This one part will represent 1 by 8. The next part will represent this much length. This will represent 1 by 8. So what we get is 1 by 8 plus 1 by 8 plus 1 by 8, that is equal to 3 by 8. So what we see is that this is the first point, second point and third point. So this third point will represent 3 by, this third one will represent 3 by 8. And we have already moved 2 units. After that we have moved 3 by 8 units. So the total we will get it is 2 plus 3 by 8, that is 2 whole 3 by 8. Next we have to draw is the point minus 1 whole 5 by 7. So minus 1 whole 5 by 7 means it will lie on the left side of 1 and on the right side of minus 2. What we are talking about is, suppose I am drawing the number line over here. So what we are saying, this is the point 0 over here, this is the point minus 1, this is the point minus 2. So what this number is, this is basically we are saying we are moving towards the left hand side, it is negative number. So how much distance we have moved over here? It is minus 1 we have already moved. This minus 1 distance we have already moved. After that what we have to do is, we have to divide it in 7 parts. So to divide the interval in 7 parts means we have to draw 6 lines over here. Now this much first distance, this will represent a distance 1 by 7. This second distance is also 1 by 7. Third one is also 1 by 7. Fourth one we have moved 1 by 7. Fifth one we have moved 1 by 7. So total distance up to this point, this to this point, it is 5 by 7. So what we are saying, this is minus 1, this is minus 5 by 7. So what basically we are doing over here, we are writing minus 1 whole 5 by 7, that is equal to minus 1 minus 5 by 7. This much distance minus 1 we have moved, and this is the distance minus 5 by 7 we have moved over here. So what we see from this is the point 0, we have moved the distance minus 1. After that we have drawn 6 lines. 6 line means we have divided it in 7 parts, and we have marked on the 5th part over here. In this point is Q point, that is the point minus 1 whole 5 by 7. Now if we have to represent the number 19 by 8, so what we are talking about is, what we are going to do is, first of all we have to locate where this number is lying. So what we do is, we divide 19 and 8. What we see is, it is 2 the 16 and the remainder is 3. It means 19 by 8 is equivalent to the number 2 whole 3 by 8. And from the last example, we already know how we can draw the number 2 whole 3 by 8, that it is just like 2 plus 3 by 8, that is we have to move 2 units, and after that in the next interval we have to find the 3 by 8th part. Similarly, the number, if I divide 12 with 7, I will get it is 7 over here, and the remainder I will get it is 5. So what we will see is, 12 by 7 is 1 whole 5 by 7, and minus 12 by 7 is minus 1 whole 5 by 7, and that is equivalent to minus 1 minus 5 by 7. It means it will lie on the left hand side. We have to move 1 unit on the left hand side, and after that we have to move minus 5 by 7 units on the left hand side, and this is how we can draw these numbers on the number line.